Hello students, welcome to the second video on sets for Kcet and JE exams. So students, in the last video we studied some basic concepts and there are total 6 examples. So let us start with the next example, that is example number 7. If a equal to x such that x equal to 4n plus 1 where n is greater than or equal to 2 and less than or equal to 5, the number of subset of A is option A 8, option B 15, option C 4, option D 16. So in this example, first given term is set A is given. Okay, so let us start with this given term first. Given term, that is A equal to x such that x is 4n plus 1 and n is greater than or equal to 2 and less than or equal to 5. Means what are the values of n here? The values of n is here greater than or equal to means 2 is included, 2, 3, 4 and this 5 also included. So the value of n is 2, 3, 4 and 5. Now by using this one, now find out what is the value of x or what is the set A here. So here set A is, so put n equal to 2 first, we will get first element. So here 4 into 2, 8 plus 1, first element is 9. Next put n equal to 3. So here 4 3s are 12 plus 1, we will get 13. Now similarly here 4, 16 plus 1. Next 5 into 4, 20 plus 1, 21. So these are the total 4 elements will get in this set A. Now this is a set A. Now by using this one, now easily we can calculate the number of subset of A here. So how to calculate the number of subsets? So one formula is there, that is formula is 2 raised to n, where n is total number of elements in the given set. So the number of subset of A are, so 2 raised to n is the formula, here n is total number of elements in the given set. So in this example, there are total 4 elements are there. The formula is 2 raised to 4, that is 16. So here total number of subsets are 16, that is option D is the correct answer. Next example number 8. If set A equal to 1, 3, 5, then number of elements in P of A. So here P means power set. So power set of A is option A 8, option B 256, option C 248 and option D 250. So student, here first given term is set A is given. Now by using this one, first you find out power set of A. Okay, that is P of A. Then once again you can apply the same formula, that power set of P of A next you have to find out. We will get the required term here. So first write down this given term A equal to 1, 3, 5. Then P of A. So P of A is, so P of A means power set of A. Power set of A is nothing but total number of subset of the given set or possible subsets of the given set is nothing but power set of A. So how to calculate power set of A? The total number of subset. Again you can apply the same formula. Total number of subset formula is 2 raised to n, where n is total number of elements in the given set. So we get 2 raised to here 3 because total number of elements are 3. So 2 raised to 3 is 8. So this one is P of A. Next P of A means already in this P of A there are total 8 subsets are there. Okay, those 8 subsets are nothing but you can consider as total 8 elements in this P of A. Now next power set of P of A is nothing but again you can find out the total subset of P of A. So total subset of P of A means you can apply the formula is 2 raised to n. So where n is total number of elements in the given set. So your given set is P of A. So your total number of elements are 8. So formula is 2 raised to 8. So 2 raised to 8 is, we get 256. So here option B is the correct answer. Next, example number 9. If A is the white set, that is pi, then P of A has just one element pi, that is P of this pi is equal to, that is singleton set pi. So number of elements of P of pi is. So student, in this example, the given term is if A is the white set means empty set. If A is the empty set, that is empty set is denoted by this pi, then P of A has just one element. P of A has just one element, that is pi. So that is P of pi means power set of this pi is nothing but will get singleton set will get pi. So number of elements of P of pi is. So there are total 4 options are given. Option A 4, option B 3, option C 5 and option D 16. So student, first you start with this given term here. What is the given term here? P of A has just one element, that is pi. This one is a P of pi is one element. One element in this flower bouquet, you can write down this pi. Now by using this one, you have to find out this term here, P of pi. So here first write down this given term, and then next, now we can calculate this P of pi. Now student, in this example, in this term, you consider this one is a one element. Then how to write the power set of this given term, power set of this P of pi? First you start with, in this power set also a set. First you take flower bucket. Then you start with first set in power set, or in subset you start with null set. So first element is, you will get pi. The second one is, for this one we can write singleton set. Singleton set means, so same thing we can write here. So we will get total how many elements we will get for P of pi? There are total 2 elements. Next, P of this term means here there are total 2 elements are there. 2 elements. Now subset of this set you have to write down. Subset of this term. So subset of this set is, again you can start with flower bouquet. You take flower bouquet and then you start with, first one is a null set. Okay, first start with null set. The next one is singleton set. So this one is a singleton set, because same thing will get here. One is pi, again pi is there. While writing sets, the element should be non-repeated. So this pi and this term both are same thing. We'll get only pi you write down, and then this singleton set means this second element you write down as it is, that is flower bouquet pi. So these are the 2 elements. Now we can start with singleton set. How many singleton set we can write here? So for this is a element. Okay, this one is a, along with bracket, this is a element. Now by using this one we can write singleton set here. Singleton set means already this one you consider as a element. For that one you take flower bucket. This is a singleton set. Now the next one is sets having 2 elements. So sets having 2 elements. This is a first element and this is a second. So this one is a fourth element will get. So this is a P of pi. So student, how many elements we got here? There are total 4 elements. So here the answer is option A. Next, example number 10. If A and B are non-empty sets, then P of A union of P of P is equal to, option A, P of A union B, option B, P of A intersection B, and option C P of A equal to P of B, and option D none of these. So student, here there are given term is there are two non-empty sets are given. Now you have to verify this term equal to P of A union of P of B is equal to. So here there are total 4 options are there. Yes, you have to verify these 4 options. Now first you start with, you take one example here. Let A is equal to, take non-empty set, that is singleton set 1, and set B equal to 2. So with this example easily we can verify these options. Now first you find out what is P of A, means power set of A. So power set of A is, in flower bracket, first null set and next one is singleton set. Similarly P of B is first one is a null set and then this singleton set. So this is P of A and this is P of B. Next, what is P of A union of P of B? So union of these two sets. So here P of A union of P of B is nothing but combining these two terms with non-repeated elements. We'll get this one is a pi, next singleton set it is 1, next one is 2. So this one is P of A union of P of B. Next, what is A union B? So what is A union B? So here A is 1 and B is 2 is there. A union B is 1 comma 2. Then by using this one, next you have to find out what is P of A union B. P means power set of A union B, means possible subset of this given set you write down. So P of A union B is equal to, so subset we can start with, first one is a null set, then singleton set you write down. Singleton set 1, next one is 2, and then the sets having 2 elements, that is 1 comma 2. Means here there are total 4 elements will get in this P of A union B. So this is the first option. Next, we can go for the second option, that is first you find out A intersection B. So second option is P of A intersection B is there. So first you take A intersection B. So A intersection B is, what is the intersection of these two sets? There is no common elements, so you will get null set. Next, P of A intersection B. So power set of this A intersection B. So subset of this null set. So the subset of null set is, you will get in this flower bracket, this is a empty set. Next, P of A is not equal to P of B, because option C is P of A is equal to P of B. So already we calculated P of A is, that is pi comma, that is singleton set 1, and P of B is pi comma 2, flower bracket 2. Now these two sets are not equal, therefore P of A is not equal to P of B. So here from equation number 1, 2, 3 and 4 we can easily write from 1, 2, 3 and 4 the option D is the correct answer, because this P of A union B, what is P of A union B? In this flower bracket, pi singleton set 1, singleton set 2. So this is P of A union B. Now compare this equation 1 with 2, 3 and 4. So we can't get the same answer. So these 3 options are not correct. So therefore option D is none of these. So option D is the correct answer. Next concept is intervals as subset of R. So in this one, first closed intervals. The set X such that X belongs to R, X is greater than or equal to A, less than or equal to B, is a closed interval and is written as closed interval A comma B. So take all the real numbers from A to B. Here A and B both numbers are included. Next one is open interval. The set X such that X belongs to R, where X is greater than A and less than B, is an open interval and is written as open interval A comma B. So the difference between this closed interval and open interval is set of all real numbers from A to B, but here A and B not included. Here set of all real numbers from A to B, here A and B are included. The next one is semi-open, semi-closed. The set X says that X belongs to R, X is greater than A and less than or equal to B is an interval written as open interval A comma B closed interval. So in this one, A is not included but B is included. So whenever closed interval is there, that value also included. The next term is the set X says that X belongs to R, X is greater than or equal to A, less than B is an interval written as closed interval A comma B. So here X is greater than or equal to is there. So here A is included but B is not included. So all the real numbers from A to B, here A is included but B is not included. The next concept is operations on sets. First one, union of sets. The union of two sets A and B is a set C which consists of all those elements which are either in A or in B, including those which are in both. We write it as A union B equal to X says that X belongs to A or X belongs to B. So the union of this A and B means combining the elements of A and B. So non-repeated elements you take from A and B. The next one is intersection of sets. The intersection of two sets A and B is a set of all those elements which belong to both A and B. We write it as A intersection B equal to X says that X belongs to A and X belongs to B. The next, properties of union and intersection. First property, A union B equal to B union of A. So these two terms are equal. So here union is commutative. So similarly, A intersection B equal to B intersection A. So here intersection also commutative. So these two terms are equal. Next, second property, A union B, union of C equal to A union B union C. And for intersection, A intersection B, intersection of C equal to A intersection B intersection C. So these two terms are equal, okay, for union as well as for intersection. So this property we call as a associative law. Number 3, A union this pi equal to A. Here pi is the empty set. So A union of empty set equal to, we get A. So this one we call as a law of identity. Next, pi intersection of A, null set or empty set intersection with A. So here intersection means common elements. Okay. So there is no common element in these two terms, we get null set. Next, similarly, universal set intersection with A equal to A because this A is always subset of universal set. So here universal set intersection with A is always A. So this term we call as a law of empty set or law of universal set. Property number 4, A union of A is always A and A intersection A also will get A. So this law we call as a idempotent law. Number 5, A intersection B union C equal to A intersection B union of A intersection C. So this one we call as a intersection distributes or union. So student, so this property easily we can remember by using, we can consider this one is a operation multiplication and this one is a addition. So if you take A into B plus C is AB plus BC. So by using that algebraic operation, so easily we can remember this property. A intersection of B union C is A intersection B union of A intersection C. Next, practical problems on union and intersection of two sets. The first one, let A and B be finite sets and A intersection B equal to empty set, then n of A union B, number of elements in A union B equal to n of A plus n of b. So this is a formula when A intersection B equal to empty set. The next one is, if A and B be finite sets such that A intersection B is not equal to empty set, then the formula is n of A union B equal to n of A plus n of B equal to minus n of A intersection B. So this is a general formula. Okay, you have to remember this one. N of A union B equal to n of A plus n of B minus n of A intersection B. Next, third formula is, if A, B and C are three finite sets, then n of A union B union C equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. So when three sets are given, then the formula is, you have to remember this formula, n of A plus n of B plus n of C minus n of A intersection B, next n of B intersection C, n of C intersection A plus n of intersection of all these three sets. Next examples. Example number 11. Let A equal to x such that x belongs to R and is mod x is less than 2, and set B is x such that x belongs to R, that is mod of x minus 2 is greater than or equal to 2, and A union B equal to R minus of C, then the set C equals option A, x such that x is greater than minus 2 less than or equal to 2, option B, x is greater than minus 2 less than or equal to 4, option C, x is greater than or equal to 2 less than 4, option D, none of these. So student, first start with the given term, write down the set A and set B. Okay, in this example you have to find out set C. Already A and B is given, so first you find out what is A union B and then you compare with this given term. So student, first you start with the given term, you write down set A and set B. This both the set, the given set builder form. First you convert, or first you find out set roster form. So first here the given term is mod x is less than 2. Mod x is less than 2 means here x is less than 2 or minus x is less than 2. So by using those two conditions we get x is greater than minus 2 and less than 2. Now similarly in this set B, mod of x minus 2 greater than or equal to 2 means first one is minus of x minus 2 is greater than or equal to 2, and second one is plus x minus of 2 greater than or equal to 2. So by using those two terms we get x minus 2 is less than or equal to minus 2, because if you multiply minus sign on both sides, inequality will be reverse. And second one is same term you can write down, x minus 2 is greater than or equal to plus 2. Now next simplify this one. The set B is here x minus 2 less than or equal to minus 2 means you take minus 2 on the right hand side, plus 2 minus 2 get cancelled, we get 0, x is less than or equal to 0. Next here minus 2 you take on the right hand side, you get plus 4, x is greater than or equal to plus 4. So by using these two terms you write down the set roster form. The first for set A, x is greater than minus 2 and less than 2, that one we can convert in terms of interval, that is open interval minus 2 comma plus 2. And set B is, see here, x is less than or equal to 0 or x is greater than or equal to 4 is there. So x is less than 0 means up to minus infinity. Here 0 is included, so we will get interval is minus infinity to plus 0, close interval. Or is there, or means you can take union. Next x is greater than or equal to 4. Greater than or equal to 4 means we will get close interval 4 comma up to infinity. So this is a set roster form. Now by using these two terms find out what is A union B. So A union B equal to, so combine these two terms here. First bracket union of next these two terms here. If you combine all these three terms, okay, so you can student, you can represent this all the intervals on number line. Then by using that one, we get r minus of close interval 2 comma 4 open interval, means from plus 2 to 4, plus 2 to 4, this 4 is not included. So this one will get A union B equal to. Now this term you can compare with this A union B equal to R minus C. We get set C equal to 2 comma 4. So by comparing these two terms, we get set C equal to close interval 2 comma 4 open interval, that is, if you convert this one in set builder form, so compare with these options. So here 2 is included, 4 is not included, means here x is greater than or equal to 2 and less than 4, that is option C is the correct answer. So students, I hope you enjoyed this video. So thank you very much for watching this video. Thank you students.